Hi guys and welcome to Learn Extra Live. It is Matt's Lit today and Indy and Haley
Hi,
are
guys.
with you. I like how I talk about myself in second person
Yeah,
or third
absolutely.
person, Indiana. So guys, today we've got an awesome show. We're going over measurement again. I think this is part of the
third session,
it's the third session.
and hopefully final session.
So
until
tell,
we do
tell us
revision.
more about measurement. Maybe a little mini recap from last week.
Well, last week we did perimeter and area. Well, the last 2 weeks. Today we're going to be doing volume and surface area, and it's going to be great.
It's going to be fun. It's going to
Yeah.
be awesome. Okay, so take
Okay,
your spot,
okay.
and I'll do my
Thanks.
usual thing. Okay, guys, what you need to do is you need to chat to us on facebook.com/learn extra. You can also chat to me on Twitter @learn extra. If there's anything that you aren't understanding, please post it on the page or tweet us and let us know so we can help you out as we go along. This page is not only for us, it's also for you, so please use it. This is our community. So let's grow it, let's make it bigger, and let's learn more and learn extra. And Haley, I think, take it away. Should we start at last week's numbers?
Started last week's numbers, so let's do it. Okay, so last week's numbers were 15, 1 to 9. Indy, what are today's numbers?
Okay, guys, I know you're not going to believe me, but today we have 15,553 likes on our Facebook page.
That is so awesome.
It's incredible.
Slowly creeping up to that 20. And I really want to be here for that 20,000 for the party.
Want the
Sure, we'll have
cake?
a huge party. I want the cake.
Yeah.
So guys, just carry on telling your friends. You know how it works. Right, let's start with today's lesson. So, if I can find, right. Last week, and the week before, we did perimeter. And we did some area. And we did some examples and questions where we included perimeter and area. Today, I want to focus on surface area and volume. So firstly, I'm going to start with surface area and then go into volume. So let's look at our shapes. So starting off surface area, it is the outside of a shape. It is the cardboard that you would actually make a shape up from. So if I look at a rectangular prism, right, I've got a box. I've got a length on the box, I've got a breadth, and I've got a height. Now, if I want to work out the surface area, I'm looking at all 6 sides to this shape. So what I've done is I've actually color-coded this shape, and I have drawn a net. So if I take this box and I actually break it down into its pieces, you will see what I mean. So I have 2 blues. Right, we can see that was our top and the bottom of the shape. Then the yellow is what's facing you and like at the back of the shape, and the greens on either side. So if I look at the net, I've got 2 rectangles that are the same, they're blue, 2 yellow ones, and finally 2 green ones. My length of my shape is still here. I've got the breadth and then the height. So this is the breadth. Okay, now this green piece is, what does this actually represent? That part of the shape, this part here, fits in there. So this is the breadth of the shape. And this part here is actually going to connect with that part there. Let's do that in a different color maybe. Okay, let's try to see the blue. Right, that part there is going to connect with that part there. So that becomes the height. So if I look at each of these shapes, and what color will work? The area of this is length times breadth. Right, the area of the yellow one is length times height. And the green one is height times breadth. So if I had to look for a formula, what do my formulas say? The formula will be 2, because I've got 2 of each shape. And then I've got my length times breadth, that's my blue. I've got the length times height, that's my yellow. And finally, I've got my breadth times height, that's my green. So we put those all into brackets because we need to consider bod mass and all those funny things. But it's the length times breadth plus the length times height plus the breadth times height, and we multiply it all by 2. You might want to do the calculations where you actually work out the length and the breadth and times by 2, the length and the height and times by 2, which you can do. Let's move on to the next shape. Right, now we've got a triangular prism. So if I look at this, I have my base of my triangle. There's my base. And I've got 2 sides, side 1 and side 2. And I also have my perpendicular height in my triangle. So what I've done is I've color-coded this. This is orange, my side 1, and yellow at the back. So if I draw this net, Right, I've got my 2 triangles, which are green. They were green in the front. Then I've got my orange, which was side 1 times by the length of the shape. I've got, and it moved. Okay, I'll put it back. The blue is the base of the triangle, the triangular prism. That's my base times my length. And my side 2 was yellow, and that's all of them. So what do we do for this surface area to calculate? We're going to work out 2 triangles plus 3 rectangles. So my equation, let's move it up a little bit, 2 triangles, and that's my formula for the triangle, half the base times the height, plus I want the area of each of these. So this is basically S1 times the length. And this is base times the length, and this one is side 2 times the length. So all I'm going to do is add those 3 rectangles. Now guys, remember, these seem complicated, but you probably will be given the formula to actually do these calculations. So within the question, they will still give you the formula you need. Let's move on to our cylinder. Now our cylinder has a blue circle at the top and a yellow, what do we call these things around a cylinder? Outside of the cylinder. Okay, and if I had to draw a net, I've got 2 blue circles because I've got the top of the cylinder and at the bottom of the cylinder. And I've got a rectangle. If I actually took this shape and unfolded it, it becomes a rectangle. What's important to note with this rectangle is that that's my height, but I'm looking for what is that measurement. Now that measurement actually goes around my circle. So it is my perimeter of my circle. So that purple there is actually 2 pi r. That's because that's the formula for the perimeter. We did that last week. So my formula will have 2 circles, pi r squared, plus my rectangle, which was 2 pi r times my height of my shape, because it's my length times my breadth. So that's where we get that part of the formula. Okay. And don't be scared if you see this formula in a different context, because sometimes they tend to write this as 2 pi r and then r plus h. I've seen it every now and again, it comes up, it's the exact same formula. So just don't be scared if you get a formula that you're not totally familiar with, because as soon as you substitute in the radius and the lengths and the heights, you will get the same answer. Let's move on to some volume. Okay, my rectangular prism, again, length, breadth, and height. What's the volume of this? My volume of the shape is just the length times the breadth times the height. And a triangular prism, well, in this case, and when you've got a shape that's not standard, like a box in a rectangular prism, we think about the common side. So in actual fact, I could give you that volume is actually the area of the common side, and I'll explain that in a moment, common side, times the height. Now, what do I mean by common side? If we look at my triangular prism, this green triangle is common throughout the shape. So if I had to cut this along that line, I would still end up with a triangle. And if I had to cut it further along, I would still end up with a triangle. So my triangle is common throughout the shape. So I need to calculate the area of the common shape, which is my triangle, times by the height, which in this case is actually my length of my prism. So let's remove that. So my formula for volume here is half the base times the height, and then I'm going to times it by the length, or if you'd like, the height of the triangle. So that's what I mean by common side. And finally, let's get to our cylinder. Cylinder, what would be my common? If I cut this, the only way I can cut it so it stays the same is if I cut it along the circle edge, so that I remain with a circle. So my formula here would be my area, moved up a little too much, my area of my common side, which is pi r squared, and times by the height of the shape, which is my h. And that's your formula. Remember, you're going to be given the formulas. So a few things that we need to keep in mind before we start with the questions is you need to be working in the same unit. And always check what unit you actually need to give your answer in, because it's always easier to convert first. So let's put this all to practice. Let's start doing a question. Right. We've got our first question, and our question says, right, Josh is learning the skill of welding. He decides to make money boxes out of rectangular sheets of metal that is 30 centimeters by 40 centimeters. Calculate the area of the thin sheet of metal, and then they've given you the formula. Use the formula, area is length times breadth. So what do we have? Area is 30 centimeters by 40 centimeters, and we can multiply that. You can use your calculator if you'd like. 30 times 40, and we get 1,200. Need a pen for that? Right, 1,200. And don't forget your units. So what were we dealing with? Centimeters. It's area, so it is always squared. Let's see what the next part of our question is. Right. His choice is a rectangular or cylindrical money box, as shown below. The cylindrical money box has a radius of 6 centimeters. Now, what I like to do, whenever I see this, okay, it's been put into your question. But whatever I like to do is whenever I see the radius, I like to write out what the radius is. So we know that the radius is equal to 6 centimeters, okay, and a height of 15 centimeters. The rectangular money box has a breadth of 8 centimeters, a length of 15, and a height of 15. So have we been given all those values? We have. Now I also like to add my L's and B's and to actually help me. So I'm going to make, that's my height, I've got my radius, and then here I'm going to say, well, okay, this is my breadth, this is my length, and that is my height. Just makes it a little bit easier for me to substitute in the values once I've got a formula. Right, the surface area of the circular money box, we use the formula, and they've given us the formula. Okay, so we need to calculate the surface area. So we're going to say our surface area is equal to, and you can get into the habit of actually writing out the formula. I'm not going to do it right now, but it is good practice. So we've got 2 times pi, and remember pi is 3,14. They're going to ask you to use pi as 3,14. And one of the main reasons they're going to ask you to do this is that we're supposed to be doing everything this year on a 4-function calculator, which means that we don't actually have that pi button. So if you're going to use your scientific calculators and press the pi button, it's not wrong, but it's always a good idea to actually follow the instructions of the question, because then your teachers are a whole lot happier when their memo is the same as your answer. So 2 times pi times my radius, what was my radius was 6, times my height, and what was my height of that was 15, plus 2 times 3,14 times my radius, which was 6 squared. And again, if you're using just a normal calculator, then you can say 6 times 6. So that's not a problem. Right, let's get our calculators out. We're going to substitute this all into the calculator. So I've got 2 times by pi times by 6 times by 15. Now, if you're using a scientific calculator, we can carry on the sum. But if we're not, let's press equals. So we've got 565.2. And let's do the second part. Okay, so now we've got 2 times pi, 3,14, times by 6 squared. So I'm going to do 6 times 6 equals 226.08. And then we're going to add those two, a little bit more space here. So on my calculator, I'm going to add my 565.2, and I get an answer of 791.28. And now it's important. What were the units? We're working out surface area, and it was in centimeters squared. Perfect. Let's move on to the next. So the next part of the question says, work out the surface area of the rectangular prism. And they give you the formula. And this formula looks different to the one we had. It's got 2 length times breadth plus 2 length times height plus 2 breadth times height. So we could use either one. But what's important is I need to know that's my length, that's my breadth, and that's my height. Especially when numbers are repeated, like in this case we've got 2 that are 15. We tend to get confused and we're not sure which ones we must do again. So let me use the formula that you were given earlier. That was length times breadth plus length times height plus breadth times height. Let's use that formula and let's get a different color. And we've got our 2 times. Now we're going to substitute. My length was 15 plus my breadth, not plus, times by my breadth, which was 8, plus my length of 15 times my height, which is 15, plus my breadth, which was 8, times by my height of 15. And just substitute one at a time. Just take it easy and just take it slowly and one at a time. And now we can actually do this calculation. And I'm going to do the calculation all at once. In fact, maybe I shouldn't. So 15 times 8 is 120. So that's 120. Now I've got the 2 times. Plus, let's do that one, and that's also 120. 15 times 15 is 225. And now if we add these all up in times by 2, so we can do that in one step on the calculator. So I'm going to add the 120 plus 120 and times it by 2. So what do I get? 930. So my answer here is actually 930, and again, centimeters squared. Okay, so it's important that you put the units in because you could lose marks for not having your units. And it's important that you work neatly and methodically and that your teacher can actually understand what you are doing and to follow your train of thought. Indy, how do you think we're doing for time? Do you think I've got time to go on to the next question?
I think let's take a little ad break.
Let's
That's
take
okay, yes, guys. I know we all need a bit of a stretch. It is Thursday. That means it's nearly the end of the week. So, guys, get up, stretch those bones, and we'll see you now after the break. Hi guys and welcome back. I hope you enjoyed that short little break and you're nice and refreshed for the rest of the show. Just in case you have forgotten to chat to me, it's facebook.com/learnextra. The page is quiet, but maybe that's because you guys are just hard at work. I know Steffi is watching. I just want to give you a bit of a wave from me and Haley. Thank you for posting on our page, Steffi, and it's so nice seeing you. Also, Doctor says that he's tired because he's been cleaning the classroom, but I think that's pretty cool that you actually got involved and cleaned your space. I think that's really awesome. So guys, don't forget to post questions on the page. We are here to help you. Any questions, even inspiring quotes. Come on guys, where's those inspiring quotes for me today? I'll read them out on the show. So, Haley, should we continue?
Absolutely.
Take
Thanks,
it
Cindy.
away.
I also think I need some inspiring quotes.
Me
That would be
too.
nice. Come
Come
on,
on.
guys. Send us something. Okay, let's carry on with the question. Right, so now we're looking for the volume of the circular money box. And they've given us the formula. And this is what I said to you guys. They're going to give you the formula, so you don't have to really panic. So let's get a orange pen. So we're looking for the volume, and we're going to do pi, which they tell us to use 3,14, times the radius squared, and our radius, if you remember correctly, was 6. We're going to do 6 times 6, and times the height, which was 15. So now we can do that on a 4-function calculator without any problems at all. So it's 3,14 times by 6 times 15, and we get our answer of 1695.6. 1695.6, and remember your units. So those are centimeters cubed. You guys have noticed, and I think I did mention it last time, I leave out my units while I'm actually doing the calculation. I just find that sometimes they confuse me. And what happens is I know that some of my grade 10s in class actually find that if they've got like a meter squared, then they think, no, they must square the number. And it sometimes can get a little bit confusing. So leave them out. They're just numbers until the very last step, and then add your units at the end. So if we've done that, we've calculated the volume of the cylindrical box. Right, what's our next question? Josh decides that it's easier to make the rectangular money box and starts a small business, making and selling money boxes. It costs him 25 Rand 50 to make one money box, including labor and overheads. He intends selling the money boxes for 30 Rand. Now the question says, calculate the percentage profit. Now, as soon as I see this percentage, I know I have to times by 100. Josh will make on each money box. Right, so we're looking at our percentage profit is our profit divided by the cost. So first we have to work out what his profit is. So his profit is actually what he sold it for minus his expense. So let's work out, he sold the money box for 30 Rand, that was his income, and he made the money boxes for 25 Rand 50. So that is what his profit was. So we can do this calculation and we'll see that it is, I think, 4 Rand 50 is what he makes per money box. But they're asking us for percentage profit. So let's change our color and let's now work out, well, we're now taking our 4 Rand 50 and we're dividing it by our expenses, by the cost. So our cost was 25 Rand 50. And it's a percentage, so we're going to times by 100. So let's get our calculator out. And we're going to say 4 Rand 50 divided by 25 Rand 50 equals, and then times by 100. And we get 17.65%. As I said that number, I lost it. 17.65. Right, and that's his percentage profit. How many money boxes will Josh need to sell in order to make a profit of at least 400 Rand? So now we're looking at, he wants to make 400 Rand. And that's pure profit that he wants to make. So we're going to divide that by how much profit did he make per money box. And let's see what that calculation gives us. And again, guys, if you want to leave out these Rand values, you can. If they confuse you here too, leave out the units, that's fine. So we can leave out the units, except my 4 disappeared. And as long as we put a unit in the final answer. So let's do our calculation. So he wants to make 400 profit, and we're going to divide it by the amount of profit he makes per money box. And we're going to see that it's 88.9. 88.9. But can he really make 88.9 money boxes? He's going to have to round that up to 89 boxes. If we rounded it down in this case, he's not going to quite make that 400 that he wants to make. So he will make a little bit more than the 400, but it said at least 400. So we've got our answer, and that's perfect. I think we're moving on to the next question. Yes, right. Okay, this is quite an interesting question. I enjoyed this. The gourmet gift basket broke the Guinness Book of World Records for the world's largest cup of coffee. And I was just saying in the break that we need a cup of coffee, indeed. Mm-hmm. They made
wink, wink, nudge, nudge.
2010 gallons of fresh coffee was brewed in a specially constructed coffee mug, breaking the previous world record of 911.5 gallons. And that was set in 2007. The coffee mug was 7 feet high, and the diameter was 7 feet. The coffee was sold afterwards, and the proceeds were donated to Susan G. Komen's Passionately Pink for the cure a program encouraging people to wear pink and raise funds for the fight of breast cancer. So these are the two things that I love about this. I love coffee and very passionate about saving and for breast cancer, so kind of appealed to me. Right, and there's a picture of our coffee mug. So remember, it was a diameter of 7 feet and it was a height of 7 feet. So now the question says, you want to write an article for your school newspaper about this record. But as the measurements are given in feet and gallons, your readers will find it difficult to understand, and probably you sitting at home are actually finding it hard to follow because we're not quite sure what a foot is. We're not quite sure how big a gallon is or how much coffee that is. So when I tell you 2010 gallons, doesn't probably compute as much as I told you in liters. So what we're going to have to do is we're going to have to convert it. So we'll find it difficult to make sense of the magnitude of the record. The diameter of the mug is 7 feet. Convert the 7 feet to meters. And it says, do not round off your answer. What do they give us? They tell us that 1 foot is equal to 0.3048 meters. And we're looking for 7 feet. So this is clearly a ratio. So I need to see, what did I do from there? I multiplied by 7, and I'm going to do the same thing here. I'm going to times by 7. So my sum is basically 7 times by 0.3048. So let's see how many meters that actually is. So 7 times by 0.3048. And we see that it is 2,1336. 2,1336 meters. Now they asked us to not round off the answer. So we're going to not round off and we're going to keep our 4 decimal places. Now if I tell you that it's 2.1 meters, you can kind of comprehend how big this coffee mug is because it's 2 meters high and 2 meters in diameter. What I want to point out before I carry on is that with this kind of question, I know you guys know you need to multiply or divide. I always get, should I multiply or should I divide is a common question I get. And I want you to make sense of the answer. 1 foot, we ended up with less meters. So I need an answer that is less than 7. And if I get an answer that's bigger than 7, then I know I've made a mistake and I've multiplied instead of divided, or I've divided instead of multiplying. So just make sense of your answer. I'm expecting a number less than 7 because that was less than that. Okay, let's move on to the next part of the question. Hey. Convert 210 gallons to liters. And we've got 1 gallon is 3,785 liters. So we know 1 gallon is equal to 3,785 liters. And now we want to know 2,010 gallons. And how many liters is that? And in this case, again, I multiplied by 2010. And I'm going to do the same thing here. I'm going to multiply by 2010. So let's do that on the calculator. Right, so I've got 2,010 gallons times by 3,785. And I get an answer of 7607.85. 7607.85. And that was liters. Now, can you see that makes a whole lot more sense to you? We've got 7,600 liters. That's a lot of coffee. And all I'm asking for is 1 little cup.
I know. Okay. 1 cup.
1 cup. Okay. And again, are we expecting a number bigger? That's much bigger. In this case, that's much bigger. So we're expecting an answer that's bigger than 2010. So I've got probably the correct answer. Let's move on to the next part of the question. Right. Calculate the radius of the mug in meters. Do not round off your answer. Now, we have calculated 7 feet in one of our previous questions. So I'm going to try and get that. It was 2,1336. We've already calculated that. So now we want to calculate our radius. And our radius, remember, was half our diameter. So if we divide that by 2, and we're going to divide that by 2. So on our calculator, right, was 2,1336. Always check that what you're entering on the calculator is in fact what it says in your books. Divided by 2, and we get 1,0668. 1,0668. So that is my radius. I'm sure we're going to have to hold on to these numbers. Maybe we should ask Indy to just keep a record of these numbers.
Okay.
I'm going to need to, we might need them later. So 1,0668 is our radius.
1,0668.
And
Yeah.
2,1336 is our height. Right, let's move on to the next part of the question. Calculate the volume of the mug and give your answer to the nearest 100 liters, where we know 1 meter cubed is 100 liters. So let's see our volume. So we're looking for our volume, and I'm going to use pi as 3,14 times by my radius, which was 1,0668.
You're much nicer than Peter.
Squared.
Peter just shouts at me the whole time. He's like, Indiana, remember the number.
I'm
You're
glad.
much kinder.
I'm glad.
Oh, hey, guys.
And times by the height, what was that?
2,1336.
Oh, thanks, Indy. You're a
Pleasure.
star. Okay, so let's do that calculation first and get our volume. Right, and remember those are meters, so we're going to get our answer in meters cubed. So let's get our calculator out, and we're going to say 3,14 times by 1,0668 cubed. No, not cubed, squared. You see, I think we must check things. Squared, and times that by 2,1, what was it? 2,1336.
Let me have a little
One.
check. 2,1336.
336. Right. And let's get our answer. So we got 7,6244. I'm going to leave it as kind of 4 decimal places. It seems 6244. Right, so we've got 7,6244 meters cubed. Was that the same answer? 6244. Right. But the question said calculate the volume and give it to the nearest 100 liters. They did not tell us to calculate the volume in meters cubed. But what they did tell us was that 1 meter cube is 1,000 liters. So in actual fact, if I had to take this 7,6244 and times it by 1,000, that will give me how many liters we have. So we can just move the decimal. So we've got 7,624,4 liters. I've just moved my decimal 3 places. And then it asked me to calculate to the nearest 100 liters. So when we're looking to simplify to 100, we're going to underline our 100. Look at the number next to it. Well, it doesn't change. So what we have, we've got 7,600 liters of coffee that they made. And that's one great world record. Okay, I think we've got enough time to work out how many mugs of coffee. Right, 1 coffee mug is 200 mils. How many mugs did they manage to sell? So we had 7,600 liters of coffee. 1 is 200 mils, but now I can't work in liters and mils, so I'm going to convert that by dividing by 1,000, the 1,000 mils in a liter, to 0,2 liters. If I divide this by 0,2 liters, that will tell me how many coffee mugs they sold. So let's get our calculator out. 7,600 divided by 0.2, and they sold 38,000 cups of coffee.
It's a lot of coffee.
That's a lot of coffee. It was going for a good cause. It really was going for a good cause. Let's see if they do more with their coffee. No, I think that we're going on to the next question. So before we go on to the next question, Andy, we got time to take a little bit of a break and they can stretch for a bit.
Yeah, let's do that. It's so funny. I'm just laughing at the page here because thank you, Lindy, for posting a picture of a cup of coffee. I think this is her way of saying, here you go, here's some coffee. If only I could sip it through the screen. Also, she posted a picture. The greater your storm, the brighter your rainbow. So there's some inspiring words for you. And just one more before I go, another really nice one from Steffi, which I think is really important. She said, it's one of her favorite quotes. It's, whether believe you can or believe you can't, you're right. And that was from Henry Ford. Have a little think about that, guys, and we'll see you now after the break. Hi guys, and welcome back to Learn Extra Live, Maths Lit. I hope you're all having an awesome time and you're chatting to us on the page. I see a whole bunch of you are starting to post. We're still laughing about Lindy's cup of coffee. It was delicious. We smelt it through the screen during the break. So, Hayley, take it away.
Thanks, Indy. Right, guys, let's start with question 3. So we've got a circular glass tabletop. It's attached to a glass stand as shown in the picture below. So let's look at the picture. Right, there's our table. The radius of the circle is 68 centimeters. Really important fact. The stand is made from 3 rectangular pieces of glass that have, so those are those 3 pieces of glass there, hope you can see them in our picture, that have a length of 1,65 meters and a breadth of 55 centimeters. Now, Indy's just looked at me and we're laughing a little bit about this 1,65 meters because clearly the table, there's got to be a typo, a mistake somewhere in this calculation because 1,65 is about as tall as I am. But we're going to go with the maths.
We had a nice little laugh about that. I was like, well, maybe it's really high table. And then we just realized, and then they're like, no, Indiana, no one's going to
sit at the table. But you know what? We've been given a calculation. So even when they don't make 100% sense, you know what? We're going to carry on doing the question as if that makes total sense. The glass components have a thickness of 60 millimeters. Now, the first thing that is standing out in my mind is that we are dealing in meters, we're dealing in centimeters, and we're dealing in millimeters. And that's our bells going off, and that we need to change those. We're not going to change them quite yet. We'll change them as we need to. Right. To protect this and strengthen the table, it is recommended that you apply a thin covering called Juror film to the glass surface. So we need to calculate the area of the Juror film that you need to cover the circular edge of the table. That is the circular top of the table. So let's see. And this particular question, we haven't been given the formulas. So I'm going to give the formula. Area of a circle is your pi times your radius squared. Now remember, we had our radius. And I'm going to work everything in centimeters. So let's... our radius was 68 centimeters. So my area is 3,14 times 68 squared. Get our calculator out. So it's 3,14 times 68 squared. And we get an answer of 14519,36. Right, 14519,36. So that is, but now don't forget your units. We're dealing in area at centimeters squared. So let's move to the next part of the question. Right, the next question says, calculate the area of the Juror form you will need to cover all the glass components that make up the stand. So we're looking at the stand. So our stand has got 3 pieces of glass, but in actual fact, we've got 6 sides to the glass. So we're going to do our length times our breadth of our rectangle. So I always like to draw the little rectangle. So we had, this was 1,65 meters tall, and it was, I think, 55 centimeters. 55 centimeters in length. So this is my first step. I'm going to change that into centimeters. So 1,65 into centimeters times by 100 gives me 165 centimeters. So my area of one side is going to be, my area is my length times my breadth. My length is 165 times 55. Let's get that answer. A little bit more space. So 165 times 55 gives me 9075. So 9075 centimeters squared. And now remember that was one side, and I've actually got 6 sides to this piece of glass. So I'm going to times that by 6 to get our final answer of 54450. 54450 centimeters squared. Now that's covering everything except for the tiny little strip on top and the tiny strips on the side. But I think we'll get to those later. So I've covered everything except for the strip here right in the front and these strips on the side. Let's move to the next part of the question. I don't have a feeling I left out part of a question.
Oh no.
I'm going to go back. That definitely was all done. I think on the first part.
No, while you're trying to find it, I'm just looking here on the page and I'm laughing. It's quite funny. Doctor says, he says, guys, sometimes your answer has to make sense. You can't leave 89.5 boxes as your final answer. So we had a laugh about that, which is completely true. But then we've got Musa, and Musa's told us, she said, that's very true. You remind me of someone in my class today that said that he gets 16,4 penguins as an answer. Guys, you can't get 16,4 penguins as an answer. Hey? Round it off.
Absolutely. And that's what's so crucial about Maths Lit, actually, Indy, is that really the context is really important. Now, I actually had a calculation which I was doing with my daughter, who's 11, so she's in grade 5. And they've just started to learn about decimals and rounding. And one of the questions was they had an oil bottle, and it was 5.95 liters, and they said round off to the nearest liter. Now, I know logically it tells me that it needs to become 6 liters. But I went to the teacher the next day and I made her laugh because I said to her, you can't round it off to 6 liters because the bottle of oil will overflow. Yeah. So, okay, but in grade 5, I think they just wanted an answer of 6. But you have to think, and that's what I love about the subject, because you're always thinking about what is the real life context.
Yeah.
I can't put more oil into the oil. Can't have a portion of a penguin.
You can't. That's just cruel.
I don't think I missed out any questions, so let's carry on. We need to calculate the volume of the glass tabletop. So our volume of our glass tabletop, we had already worked out the area, but in fact our volume is, pi r squared times the height. Well, it doesn't look like an r. So it's 3,14 times my radius of 68 squared times my height. But now in this case, what was the height of my shape? That was the thickness. That's the height. The height is that tiny little thing there, and it's 60 millimeters. I need to convert that into centimeters, so it becomes 6 centimeters. So my volume for this tabletop is times by 6. So let's get an answer for that. Get our calculator out, and it was 3,14 times 68 squared times 6, and we get an answer of 87116. 87116, and we're dealing in centimeters cubed. We've got to calculate the volume of the stand. So now we're going to calculate 1, and remember we've got 3 parts of the stand. So we're going to calculate 1, and a volume of 1, and then we're going to times it by 3. So our volume was length times breadth times height, and our length in this case was 165. Our height we said was 55. I think we got those the other way around. And again, our thickness was 6. So we're going to do that calculation, and now all of those we need to times by 3. So let's get our calculator out. So it's 165 times by 55 times 6. I'm going to get an answer 54450, and I'm going to times that by 3 because there are 3 glass pieces. So 163350. And again, what are we dealing with? Centimeters cubed. So have we answered the question correctly? We've said the volume of the stand. Let's see if we move on to the next part of the question. Now, the next part is, what are the dimensions of the box that a fully assembled table can fit into? So now we need to look at putting this whole thing into a box, fully assembled. So what we're looking for is the length and the breadth of the box are going to be the top of your table. So if I put it into the box, let's imagine the box that way, and I'm going to put my circular part is going to give me 2 dimensions of the box. So what do I know about this? I know that my radius was 68. So my diameter here is 68 times 2. 68 times 2 is going to give me 136. So my box, let's draw our box here. So we've got our box, we need a length, we need a color here. A length we're going to have, doesn't look like an L, a length of 136 centimeters. Go back to this, so that's 136. And I need a breadth of 136, because remember it's a circle, so it fits into a square shape. And finally, my height, which is kind of going out of the board or into the board, is going to be that part there. And that part there was the 165 centimeters. So my dimensions are 136 by 136 centimeters by 165 centimeters. So those are my dimensions of the box. Now you can write your dimensions like this, or you can actually say, well, the length was 136, the other breadth was 136, and the height was 165. How much packing material would be needed to add to this box to protect the fully assembled table? Now what we need to do for this one is we need to work out the volume of this box. And then to work out our total volume of our table, which we've done in 2 steps earlier, and minus the 2. So let's see how far we get. I'm not sure how much time we have left. So let's see how far we can get. We're going to work out the volume of the box. So let's get our calculator out. And we're going to say, right, 136 times 136 times by 165. We're going to get an answer of, right, 3 million, and we're dealing in big numbers. And the reason we're dealing in big numbers is because I've been dealing in centimeters. You could have changed this and worked all in meters, and it would have maybe made it a little bit easier, but I'm happy in centimeters. So 3,051,840. 3,051, no, I've lost that, 840. Those are centimeters cubed. And I'm going to minus. And in actual fact, I'm not going to do the calculation, but remember we did the calculation of the tabletop, the volume, and we did the volume of the 3 pieces for the stand. So we would minus the tabletop and the stand. I'm not going to do it right now for you. And you would get a total. And the balance is what you need is your packaging material that you need to protect this table. So I think that, I think that that will give you enough information for you to finish this on your own. And I might have enough time to just say, would you recommend this to manufacturer? Now, what I'm going to tell you is that you're going to end up with a huge amount of wasted space and a huge amount of protection material that you need. It might be better to actually flatten this and send it as the tabletop and the 4 stands. You're going to need a much thinner box, and you'll have much more less wasted space. But on that note, I think I'm going to have to say goodbye to you and hand you over to Indy, who's going to say goodbye.
Sheesh, I can't believe. Is this the end of the show?
I
It's
can't
gone
believe
so
it.
fast. We've enjoyed it so much. Tanya says, love the show. Keep up the good work. YOLO to all the mindsetters. So YOLO back, mindsetter. And I hope that you really enjoyed the show, learning more and learning extra.
What else have we got on the page?
And Steffi said, this last question, she actually had the exact same question in her exam about the table, and I did say to her, I said, was the table that high? And she said, yes, but it wasn't that tall.
It wasn't that
It
tall.
wasn't that tall, so there must be some kind of like error. But we still worked it out anyway.
I actually think that what we did, who did you say to say that?
That was Steffi.
Steffi, we had this question that actually based on a question that I've also seen before with the tabletop, but if you'll notice and go back to your exam, you'll see that we've actually changed the question slightly. And I think that's where our gremlin of our 1.65 meters actually came in, because while we were typing it, it seemed to make a whole lot of sense. And as I was trying to teach it, it kind of like stood out and said, So you will often see that the questions are adapted and changed a little bit from time to time. So it's very similar to what you had.
Awesome. Okay, grade 10s. We've had such an awesome show. Thank you so much for learning more, learning extra. Grade 11's you next, so stay tuned. See you grade 10, same time, same place next week. Bye.